In this lesson, you're going to learn about arithmetic sequences and series. So what exactly is an arithmetic sequence and an arithmetic series? Well, a sequence is basically a list of numbers, and a series represents a sum of numbers. Now, when we talk about arithmetic, what we're talking about is that you're adding the same quantity each time to get to the next number, the next term in the sequence. And so it's a consistent pattern there. And what we call that thing that you're adding each time, we call that D, the common difference. And I'll show you an example to illustrate how to work with these two formulas we're going to be working with here. One is the rule or formula for finding a particular term in an arithmetic sequence. That's this one here. And then the sum, if you want to find the sum of the first 10 terms, 20 terms, 100 terms, however many terms. So let me show you an example, and I'll kind of go through it as we go. So for letter A here, we've got this sequence, this list of numbers, 3, 5, 7, 9, 11, ... So what exactly are we adding to get to the next number? Well, you can see that we're adding 2, and that's what we call our common difference, our D value here. Now, when you talk about sequences, there's a couple things you want to pay attention to. One is that, you see how I have written n equals 1, n equals 2, n equals 3? That's the term that we're talking about, the term number. But see this a sub 1, a sub 2, a sub 3? That represents the value of the term. Now when I say sub, I mean like subscript. So a sub 1 means, 1 is a subscript, but it's basically referring to what's the value of that first term, what's the value of the second term, etc. So when we look at this formula, if we want to find, a formula for this pattern here, what we would do is we'd say a sub n, meaning the value of our nth term, equals the value of the first term, which in this case you can see is 3, plus the common difference. Okay, you can see we keep adding that difference of 2. Now the reason they call it the difference is if you take 5 minus 3, see, the difference between 5 and 3, you get 2. 7 minus 5, you take the number minus the one before it. And then we've got n minus 1. So this is a formula. Now if you want, you can distribute the 2 into the parentheses here and combine like terms, but for right now I'm just going to leave it like that. But if we want to find the sixth term, a sub 6, we would take the first term, which is 3, plus the common difference 2, and now this n tells us what term we're on. That's the sixth term we want, minus 1. 6 minus 1 is 5, times 2 is 10, plus 3 is 13. So you can see the value of that sixth term is 13. Now I just want to explain a little bit how the formula works, just so you can understand a little bit better. See, here's 1, 2, 3, 4, 5. Here's our sixth term right here. But we're starting at 3, and we're adding 2 once, twice, 3 times, 4 times, 5 times. How come not 6 times? We're on the sixth term, right? Well, because we already started at the first term, we only have to add that common difference n minus 1 times. Okay, so that's where this n minus 1 is coming from. We're just adding that common difference of 2 5 times, not 6, and then we're adding that to the first term. So that's where the formula comes from. Now let's do this other one, a sub 100. Well, you wouldn't want to add 2, until you got to the 100th term. That would take quite a bit of time. So that's where the formula really benefits you. So we start at 3, that's our first term. We're adding 2 99 times, not 100, 100 minus 1, 99. So that's 198 plus 3, which gives us 201, and you've got it. Okay, let's go to another. Want to learn Algebra 2? Check out my Learn Algebra 2 video course for sale, where we go through 85 video lessons that take you step by step by step through Algebra 2. We go through the important formulas, concepts, as well as numerous examples to help you master Algebra 2. Click the interactive card or the link in the description below to go over and check out some of the free lessons. Otherwise, let's get back into this current lesson. You've got it. Okay, let's go to another example now. So for letter B, what we're going to do is we're going to find the sum of the first 6 terms. So see how this subscript here, 6, tells us we're finding the sum, S for sum, the first 6 terms. Now you might say, well, Mario, I can just go ahead and add those 6 numbers together, and that's fine. But what happens is, say you wanted to find the sum of the first 100 terms, it would take quite a bit more time to first write them all out and then add them all up. So let's just go ahead and I want to show you a pattern here. So notice if you add 3 and 13 together, you get 16. See how if you add 5 and 11 together, you get 16? And if you add 7 and 9 together, see how you get 16? Very interesting pattern. So what we're doing is we're taking the first term, a sub n is like your last term, so you're adding the first term for the last term. So notice we're taking 3 plus 13 is 16, times the number of terms divided by 2. Now why the number of terms divided by 2? Well, remember how we said we got 16? But how many 16s did we get? Did we get 6 16s? No, we had half that many because we're pairing 2 numbers together each time. We're actually only getting 3 16s, which you can see is 6 divided by 2. That's 3. So 3 times 16, we get a sum of 48. So just trying to show you and give you a feel for how these formulas work. First term plus the last term times the number of terms divided by 2, so half the number of terms. Because you're pairing them, first and last, second and last, you're going to have half as many of those groups. Okay, let's go down to letter C. Now what we're talking about in letter C, these are all introductory examples. I'm going to have some that you can practice on your own, but to show you the notation here, see this kind of squiggly line here? This is the Greek letter sigma, and this represents the summation or the sum. What we've done here, instead of just writing it as a list like so, what we're doing is we're writing it in a compact form. I is what we call our index. What you do is you start at this bottom number here, I equals 1. You put it in for I here. 3 times 1 is 3, plus 2 is 5. That's our first term. Now the sigma or the sum just means that you're adding each term. And you work your way up sequentially from 1 to 8. So the next term would be 2. So we put 2 in. 3 times 2 is 6, plus 2 is 8. We put the next one in, 3. We get 9 plus 2 is 11. And until you get to the 8th term, 3 times 8 is 24, plus 2 is 26. Okay, and again, so all we're doing is we're finding the sum. This is just a compact way of writing that as a summation. So they call this sigma notation. So what we want to do here is we want to use our sum formula, which is this one right here. We're finding the sum of the first 8 terms. There's 8 terms, so 8 divided by 2. The first term we know is 5, and the last term we know is 26. And if we simplify, you can see 8 divided by 2 is 4. 5 plus 26 is 31, so that gives us 124, and it saves us from having to write all those out and add them together. Okay, let's go to example D here now. It says write a rule, basically that just means like a formula, for this sequence here and find the 30th term, okay, the value of the 30th term. Well, let's see the pattern here. What are we doing to get from the first term to the next term, etc.? Well, it looks like we're subtracting 5, right? So if we use our formula here, this one at the top, we've got our first term is 12. Our common difference is a negative 5. You could write minus 5 or plus a negative 5 times n minus 1. Now here what I'm going to do is I'm going to distribute the negative 5. I'm going to simplify this down a little bit for us. So negative 5n plus 5 plus 12. So this comes out to negative 5n plus 17. That's a formula for any term. Now if we want to find the 30th term, a sub 30, we're going to put 30 in for n. So negative 5 times 30. That's a negative 150, plus 17 is what? 133, and it'll be negative. So don't get confused. When you see these subscripts, see this doesn't mean s times n. It's really telling you, oh, that's the nth, that's n number of terms that we're finding the sum for. Same thing here. It's not, again, it's not like a times n or a times 1. This just means the value of the first term, the value of the nth term, or in this case, the nth term represents the last term that we're trying to find the sum of. Okay, let's look at example E here. It says write a rule given that the third term is 8 and the sixth term is 23. Okay, so this is very interesting. We've got 2 pieces of information about this sequence. We've got 1, 2, the third term is 8, 4, 5, the sixth term is 23. Now there's a lot of different ways to do these problems. Assuming this is an arithmetic sequence here, we could just say, well, 8 plus d, that's our common difference, plus d again, plus d again. So we could say 8 plus 3d equals 23 and solve that for the common difference. So here I'll do that. That's 3d is equal to 15, so you can see d is equal to 5. So that means if we're adding 5, so this would be 13, 18, 23. And if we worked our way backwards, this would be then be 3, and this would be negative 2, right? So now we have the first term, we have the common difference. We could write our formula. Sometimes they're not so easy like that. So what I want to show you is another method, and that's what I'm going to do is I'm going to write a system of equations. So what we're going to do is the first term we know is, well, let's pretend we don't know the first term. Okay, say it's a sub 1. The common difference we also don't know, but let's say we know the third term. So 3 minus 1 is 2, right? And the value of that third term is 8. So that's our first equation. The second one, we know the 23 is the value of the sixth term. So 23, I'm putting in the value of the sixth term. The first term, let's say we don't know. The difference, let's say we don't know. But we know that 6 minus 1 is 5. So now we've got 2 equations with 2 variables, a sub 1 and d. What I'm going to do here is I'm just going to subtract, okay, using the elimination method. So the a1s are going to cancel. 2d minus 5d is negative 3d. 8 minus 23 is negative 15. If I divide by negative 3, you can see d equals 5. Same thing we got here. Okay, just doing it a different way. And if we put 5 back in, I'll put it into the top equation. That's going to be 10. If I subtract 10, you can see that a sub 1 is equal to negative 2. So now if we put it all back together into a formula, we've got a sub n equals our first term, which is negative 2, and we keep adding 5 n minus 1 times. We can simplify this a little bit. 5n minus 5. Combine like terms, we get 5n minus 7. That's our formula. If you want to test it out, let's see, the sixth term would be 30 minus 7. Yep, that's 23. You know, you can verify. Okay, let's go to letter F and letter G. Now, we're doing some more summations here, you can see. Notice for this one, we've got 8 terms, 1 through 8. Whereas for this one, you see we have how many terms from 4 to 12. So you start at that bottom index, you work your way up sequentially to the top number here. How many numbers do you think there are between 4 and 12? Well, if you said 8, you're close. It's actually going to be 9. And the reason is, if you count the first number and the last number, like say if I say how many numbers are there from 1 to 5, well, 5 minus 1 is 4, right? But you can see there's five numbers there. So when you subtract, you want to add one more if you're counting the first and last term like that. So just a note there. So let's see if we can do this one. So we've got 8 terms. So we're going to find the sum of the first 8 terms. 8 divided by 2. Now the first term, how do we find the first term? We put 1 in. Okay, so negative 1 plus 6 is 5. How do we find the nth term, or in this case the 8th term? That's the last term. We put in 8. It's 48 minus 1, which is 47. So we have 4 times 52, which is 208. Okay. For letter G, same thing. You can see here we said there's 9 terms, so it's 9 divided by 2. The first term we're going to put in is 4, so that's 28 plus 3, which is 31. And we put the 12th term in to get the last term. That's 84 plus 3, which is 87. And you can see this, if you simplify that, that's going to give you the value of the sum of the first, well, not the first, but the terms from 4 to 12. So let me erase the whiteboard. I've got one more introductory example, and I've got some problems you can practice on your own so you can get some more experience. Okay, letter H, we've got a summation here. I equals 1 to n of 2 plus 10i, and that sum equals 160. So here what we have to do is we have to work backwards and find out the number of terms that are in this series. So what we're going to do here is we're going to look at our formula. We know that the sum is 160. We know the number of terms right now is n. That's what we're actually solving for. The first term, if we put 1 in, you can see that's going to be 10 plus 2, which is 12. And the last term, a sub n, over here, if we're going to put n in, we get 2 plus 10n. Okay, so all we have to do now is solve this equation for n, and we've got it. So let's simplify a little bit here. I'm going to multiply both sides by 2 to get rid of this 2. So that's going to be 320 equals n times 14 plus 10n. If I distribute the n, I get 10n squared plus 14n. And I'm going to subtract the 320 to this side so we can set everything equal to 0. Now you could do the quadratic formula, or you could factor. Let's see, I'm going to factor this. Let me see, how would this factor? Well, first I'm going to divide everything by 2 to make it a little bit easier. So 5n squared plus 7n minus 160 equals 0. And if we factor this, it should factor to, let's see, 32 and negative 5. So 32n and negative 25n adds up to 7n. So if we set these groups equal to 0, you can see that n is going to equal 5, or n is going to equal negative 7. Now we can't have a negative number of terms. That doesn't make any sense. Actually, that's not negative 7. That's actually like negative 32 fifths. But we can't have a negative number of terms, so we can see that's extraneous. It's just going to be n equals 5. There's 5 terms in the sequence, and you got it. Okay, so here's your opportunity to practice. So pause the video, see if you can do the problems on your own, get some practice, and then we'll go through them. So the first one, it says, write a rule for this arithmetic sequence we have here, and then find the 10th term, the value of the 10th term. So how would you do that one? What do you think? Well, if I was doing this problem, the first thing I would do is I'd look to see, what's the pattern, what are we adding to get to the next term? It looks like we're adding 4. So our formula is going to look like this. A sub n equals a sub 1, which is negative 6. I'm just using this formula right here. The common difference is what we're adding to get to the next term. That's 4 times n minus 1. I'm going to distribute the 4. That gives us 4n minus 4 And if we combine like terms here, you can see that's going to come out to a sub n equals 4n minus 10. Now, sometimes I like to check my work just to see if I'm on the right track. So if I put in, let's see, 1, 2, 3, 4, let's say the fifth term, 4 times 5 is 20 minus 10 equals 10. You know, it checks out. Okay, how would you do number 2? Now, for number 2, what we want to do is we want to find the sum of the first 18 terms. So we're treating this as a series now. A series means a sum as opposed to a sequence, which is just a list. So what would the sum be of the first 18 terms? What do you think for that one? Okay, if I was going to do this one, I would use this formula right here. The sum of the first 18 terms is going to be 18 divided by 2, because n is 18. A sub 1 is our first term, which we know is negative 6. And then our 18th term, we have to put in 18 here. That would be 4 times 18, which is how much? 72 minus 10, which is 62. So 18 divided by 2 is 9. This comes out to, what is that, 56? Is that right? Okay, and then 9 times 50 is 450. And 9 times 6 is 54. So it looks like we're coming out to a sum of 504. Okay, so that's the key for that one. So for number 3 now, we've got our summation notation. We're trying to find the sum of the first 15 terms of this series. What do you think for that one? How would you do that one? Well, if I was going to do it, again, I would be using this formula here. We've got the sum of the first 15 terms. So we have 15 divided by 2. The first term would be 8 times 1 is 8 plus 1 is 9. The 15th term is going to be 8 times 15, which is 120, plus 1 is 121. So that comes out to 130 times 7.5. Or let's do it this way. Instead of 7.5, we'll do 15 over 2. 2 goes in here once, 2 goes in here 65 times. So it's 15 times 65. Let's calculate that. 15 times 65. Looks like we're getting 975. So check your work on that one. Check my work, I should say, on that one. Okay, let's go to the next one, number 4. So this one, the fifth term is 9. The common difference is 3. This is an arithmetic sequence. We want to write a rule for any term in that sequence. So what we're going to do is we're going to use this formula here. We've got, sometimes what I like to do, and this is just a good hint just in general when you're doing some of these math problems, is, you know, write down the formula first. Number 1, to help you memorize it. Number 2, to kind of organize your thoughts. Number 3, so you can kind of substitute in what you know, and then you can solve for what you don't know. So in this case, we know that the fifth term is 9. So I'm going to put that here. The first term I don't know. The difference they gave us was 3. And let's see, we're working with the fifth term, so this is 5 minus 1. So it makes it a little bit easier than trying to do it all in your head. 4 times 3 is 12. If I subtract 12, I get negative 3. So the first term is negative 3. If we put that back in, now we can write our formula. So we have negative 3 is the first term. The common difference is 3. And if we simplify, we get 3n minus 3 minus 3. Okay, so if we put that all together, we get a sub n is equal to 3n minus 6. Now I always like to check my work a little bit just to see if I'm on the right track. So let's just put 5 in here. That's 15 minus 6 is 9. Okay, so we can see we didn't make any little arithmetic errors or anything like that. Okay, try number 5 now. So here they're giving us the second term is negative 2. The sixth term is positive 2. How can we write a rule for this arithmetic sequence given those two terms? Go ahead and pause the video, see if you can do that one. If I was going to do it, I would write a system of equations. I would say negative 2 equals a sub 1 plus d times 2 minus 1, which is 1. And the sixth term is 2, so a sub 1 plus d times 6 minus 1, which is 5. If we subtract, negative 1 minus 2 is negative 4. These a sub 1's cancel. 1d minus 5d is negative 4d. And if we divide by negative 4, you can see that common difference is 1. If we put 1 back in for d, let's say right here, 1 times 1 is 1. If I subtract the 1, you can see a sub 1 is equal to negative 3. So now, if we put it all back together, the first term is negative 3. The common difference is 1. And we can distribute the 1. That's n minus 1. So that gives us n minus 4 equals a sub n. So if we want to check it out, let's test. So the second term would be 2 minus 4 is negative 2. The sixth term, 6 minus 4 is 2. So you can see we've got a good formula for the sequence here. Okay, this last problem, number 6 here, I made a mistake when I first wrote it down. It's actually equal to negative 16. So what we're trying to do is we're trying to find this missing value n. This is the sum of the first n terms of this arithmetic series, and it equals negative 16. So how would you do that problem? Well, if I was going to do it, I'd be using this formula up here. I'd say that the sum is negative 16. There's n terms. We don't know how many. And the first term, if we put 1 in, we get 7 minus 2 times 1. 7 minus 2 is 5. And the last term, the nth term, we don't know what that is, but if we put n in, we get 7 minus 2n. So we have an expression for the nth term. All we have to do is solve for n. I'm going to multiply both sides by 2. That comes out to negative 32 equals n. 12 minus 2n, just combining like terms. And then if we distribute the n, you can see we're getting negative 2n squared plus 12n. I'm going to add the 32 to the other side, set this equal to 0. I'm going to divide everything by negative 2 just to make it a little bit easier to factor or solve. And so now what we're going to do is we're going to factor and set the factors equal to 0. So, or you could do the quadratic formula. So this looks like it's going to be negative 8 and positive 2. So that's negative 8n plus 2n is negative 6n. This multiplies to negative 16. If we set each factor to 0, we get n equals 8 or negative 2. Now we can't have a negative 2 number of terms. That wouldn't really make any sense. That's extraneous. So there's going to be 8 terms in this series, and they'll all add up to negative 16. So great job. I hope you understand this concept. Otherwise, go back and review the video. There's a couple of formulas for your formula sheet to memorize. Otherwise, I'll see you in the next lesson.